ma. Welcome, ma. Good evening, Madam Uduak. Good evening, Madam Olakweju. Aliyah joined us today. Good evening, Aliyah. Good evening, Mr. Lawrence. Good evening, Biola. Good evening, Madam Susan. Welcome. Welcome.
Aliyah, my cosmates.
Exactly.
When I saw her name, oh, I welcome you, Aliyah.
All right.
Thank you
welcome,
very much,
everyone.
please.
Yeah.
Good evening, sir.
Good evening, ma. Welcome, everyone. All right, today we're just going to wrap up on calculated columns and this as well.
Measurement, right?
Measures. Yes, calculated columns and measures. I know the network is terrible across the nation, especially with the rain, or maybe across Lagos. Let me say across the nation, across Lagos, because of the rain. But please just stick with me as we proceed in our procedure this evening. All right, so we're just going to get right into it straight up and see how much we can do. Power BI is, remember that the goal of this training is to get you up to speed. There's a lot to learn in Power BI and SQL, right? But the goal is to be able to skill you up to have enough knowledge to be able to, get on the job and do, right, and work, right? So I would, after this training, there's still more to learn, right? There's the administrative part of Power BI that we can't even go into, right? The same way we can't go into the administrative part of what's called SQL, right? So, but how to be able to go from zero to developing what's it called, beautiful reports is what we are trying to do today. So please, it's what this training is all about. So please let us put that in mind, right? After the training, I'll share more resources on us with us via video links and materials that we can leverage on to get more deepened understanding about the concept of SQL and Power BI. But remember, the goal of this training was to be able to get you ready for the job, skill you up, right? So, and I believe that at the moment, right, I can categorically say that you are good SQL developers and good Power BI developers as well, or Power BI users, right? So, please, if you have not started, or if your interest has dwindled, please don't let it, right? After this class, we finish tomorrow, right? Want to be able to go deep, consume the materials over and over again, all right, and use them, especially when you want to do your projects. The projects, I'm going to send the project to our emails this night. We have 2 projects, one for SQL and one for Power BI, and it will be the same project for everybody, so you can collaborate in doing your project. But we're going to be submitting individually so that we can get our certificates, right? So it's very important for us to know that, right? Also, you might not get everything in class, right? That is why the classes are recorded. So please try and engage these videos to get more, to deepen your understanding, right? So the last time we had class, I think I stopped at, where did I stop? Who can tell me first? All right. I'm just going to pick, I think, hold on. I have a lot to talk about, right? But I'm just going to compress all that I need to talk about into one. And at the end of the training also, at the end of this training, I'm going to send you my Power BIX, right, for this class so that you can see all the components that were built in the inside of them, right? So that you can also get your components up to speed. So, but I would encourage that you use the video to also, build along as we're building. You get, especially for the calculated columns and measures that we have created, right? If you look at it, I have some more here that were not created in class, right? So we'll look at how to create some of them today, and we'll move on from there. So please pay attention. All right, I want to switch to the Power BI for class. All right, so we were talking about data analysis expression, and we said that data analysis expression can be used to create can be used in two ways, or can be used to create two things, right? Calculated columns and measures. These calculated columns and measures are basically how we do the analysis, right? How we do the analysis. Yes. Very important before I proceed. Opportunity actually for those who are interested in, if you're interested in writing your Power BI exam, right? I would advise that you write your Power BI exam. I know one or two persons who are already on their way to do that, right? If you're interested in writing your Power BI exam, right? This qualifies you as a Microsoft data analyst, right? I think I've shown us this at the very beginning of the program, right? It's very important. It increases your chances to get opportunities, either remote or either organizational engagement or freelance work, right? And of course, it exposes you to more knowledge about Power BI. Please, if you are interested, please reach out to me. I would encourage everybody to do that, right? I will encourage everybody to do that if possible, every single person, right? The exam is not expensive. It's about $80, $90, I think, right? And I think put together you have to be able to get some materials that you use to prepare, right? So please just reach out to me if you're interested. I encourage us strongly to do that. I encourage strongly to do that so that you not be left behind, and you have an understanding and get something to really show forth for your knowledge, right? You get something to show forth your knowledge, right? So that it will not be certifications that would deny you of opportunities. So please, if you're interested, reach out to me in my inbox or in my DM. I would gladly talk to you about it. Thank you. All right. So we talked about data analysis expressions. I would say data analysis expressions are used to generate both calculated columns and measures. And calculated columns and measures help us get deeper understanding of the data, right? Basically, we use calculated columns and measures to express business cases in the data. Business cases like you want to know the total quantity sold, you want to know the total orders generated, you want to know if a customer is the parent or not, you want to know what is the start date of the you want to know your number of orders generated, you want to know if a particular what's it called item, right? If a particular order has a single item or multiple items inside of it, and so on and so forth, right? So we looked at, you want to know I'm giving examples now. You want to know if an income, you want to be able to divide your income level or incomes of your customers into multiple levels, right? Of very high, average, and low income, so that you can profile your customers. So all of these you can do with data analysis expression. So it's very, very important for us to understand them, right? And we started talking about them already, and we said data analysis expression, right? You can perform data analysis expression. You can perform logical operations. You can perform statistical operations. You can perform mathematical operations. You can even perform filters, right? Filters, right? Filters. We've not been able to talk about filters. Also, hoping that we're going to talk about the filter functions last week. But we can even work with text like in Excel. And I remember telling us last week that most of the Excel functions, or most of the functions that we have in Excel, most of the formulas that you have in Excel are also present here, right? They're also present here, right? Except for a few others that are Power BI specific functions, right? So we'll look at a few of them again. I'll do a bit of recap, right? I'll do a bit of recap so that we can bring ourselves up to speed. I hope that a few of us were able to look at the videos last class, coming. Wow, this seems fresh. What did I? All right, this seems very fresh. Didn't I save my work from last week? All right, let's go to data view and get cracking. Let's go to data view and get cracking. All right, so we have the date. I'm going to convert these dates to short dates so that they are ready for use. And I'm going to be answering a few questions. Last, we answered a few business cases. So I'm going to be answering a few business cases today so that I can cut across all the topics or the parts that I can talk about. Because tomorrow, right, the visualization part is the easiest part of it. That is what we're going to be doing tomorrow. Tomorrow class will be starting a bit early, right? We'll start by 6 tomorrow so that we can end class, the whole program tomorrow. I don't want us to extend it one more day, right? So just follow me, all right? I want you to pay attention. You might not be able to replicate exactly what I'm doing or replicate it immediately I'm doing them, but just follow me so that we're all on the same page, right? I'm going to be starting with, let's look at a few business cases let's start with a few business cases that we talked about last class, right? So you have this data, right? You have this data set, and you are asked to look at your customer table, right? Look at your customer table, right? And on your customer table, you can see that there is a column that says, where is it now? Total children, right? Total children. Can you see that column that says total children, right? If you click on it, you see that your values range from 0 to 5. So some people have children and some do not have children. So we want to be able to make sense of that data, right? And make it a categorical data, right? This time around, we want to be able to generate a new column. Remember, I've told you that when you want to create a new column, you use calculated columns. And when you want to create when your result is a single result, when your result is going to be a single result, what do? You create a measure. You create a measure. If you're going to be if your result is going to be singular, right? You create a measure. Right? So let me bring my note out so that we can express that in. All right, this business case, I think we solved last class. So we'll start from there just to refresh before I move into more advanced ones, right? So last class, we talked about business cases like, so let's start with categorize using categorize the customers to, or let's do it this way, create a parent column that tells if a customer is a parent or not, right? A parent or not, right? Use yes and no as the categories for the column. Create a parent column. So I hope you're following. So create a parent column. Please let me know if you can hear me, right? Create a parent column that tells if a customer is a parent or not. Use yes or no as the categories for the column. Right. So I'm going to go into my customers table, right, or my customer query, right? And I'm going to just right click. I've told you, right? What you want to do is you expand your table and you right click. You can right click anywhere in the table or right on the table itself, right? And so you can see new measure or new column, or you come here and do the same new measure or new column. So I'm going to say new column, all right, new column. And this time around, I'm going to be using an if statement. I'm going to be using an if statement. I'm going to be using an if statement. So I'm going to call this parent. That's the name of the column, right? So we say equals to parent equals to. Now we say, remember, the data is coming from what? The data is coming from the customers table. So we say AW customer, right? So we're looking for the total children column, right? That is that, right? So we say, sorry, start with an if statement. If total children, right, which is coming from the AW customer table, if total children is greater than 0, are you following me? If total children is greater than 0, right, do what? Return what? Yes. That is, the person is a parent. Else, return what? Return no. This is a simple dark statement that utilizes what's it called? If statement, right? We are familiar with if statement, right? So if we run this statement now, right? If we run this statement, a new column is generated that helps us automatically generate a result per row, right? It generates a result per row using what we call it uses what we call a filter context, right? A filter context will generate a result per row, right? So it says where this person, where this role generate for this row, generate for this row. So it does an iteration on all the rows and generate a value for them. So if you look at the values in the parent column, what you see is a no and yes, what? Yes variable, right? Like we mentioned in that statement. Right? Give me thumbs up if you understand that, right? If you understand that, please give me a thumbs up before we proceed. Give a thumbs up before we proceed. Awesome. Waiting for others. I'm waiting for others. Right? So that is one business case that we've just looked at, right? So if you look at the data now, we have what? We have a parent column that is generated as a calculated column that tells us if a customer is a parent or not, right? That is one. Two, let's look at another business case. Let's look at another business case. We want to look at the sales table. Let's take a dive into the sales table a little bit. Right, we'll be using the sales table a lot, but let's take a quick dive into it. Right, so I'm just going to go to in the data view. Right, I'm going to see my sales table. Right, so the sales table tells us the order date, the stock date, the order number. This order number, of course, has values replicated inside of it. Right, duplicate values basically. The key, the product key, the customer key, the territory key where the sales is coming from. The order line item, basically what item or what combination of item did the person buy. So this person bought an order called 360, right? An order that has a key 360, right? So in a single order, you can have multiple items, right? Each of those items are registered, but they'll be registered with what? With the same order name. We'll talk about how to look at distinct orders and all of that much later, right? So we have order line and we have order quantity, right? So we want to know, right? One quick want to generate a column, right? I'm still doing a recap. I hope we can cover a lot today. right? Create a new column that informs if an order contains single items or multiple items. So we want to know if an order contains single item or multiple item, right? So how do we do that? We go back to our data, right? From the quantity, order quantity, right? You would see that the values inside of it, right, is 1, 2, 3. So there are some orders that are just one singular orders. There are some orders that are multiple orders, right? We want to be able to categorize these orders, right, in terms of description to either being a single order or multiple order. So what do? We create a new column. Remember that the statement says create a new column, so we create a new column, right? We create a new column. And we use an if statement to what? So we say quantity type equals if AW sales order quantity is greater than 0 or is greater than 1, all right? Return what? Multiple item. Else, our first value will be what? Single item. Right? We run that. What do we have? We have a new column that says quantity types and tells us if the order is either a single order or a multiple order. Can you see multiple items, single items? So if we scroll down, we'll see multiple items below, right? You see, right? Can you see multiple items, items that are way more than 2 and all of that, right? I hope we're following. All right. I want to quickly answer a bit of business cases here as well. I have them written down. Some of them are in the questions that I sent to you. Remember, I sent you a lot of questions, right? I sent us a lot of questions that that talks more about that points to what we're doing, right? I hope that we've been able to look at them, right? Let's see. All right. We want to be able to look at another business case here. Let's look at the customer table. Let's look at the customer table, right? We want to be able to generate the current age of the customer, right? In this situation, we want to work with date a little bit, right? We want to work with date a little bit, right? We want to be able to generate the age of the customer, right? So let's look at the table itself, right? So we know the birthday of the customer. Can you see the birthday of the customer, right? And we know that if we subtract the birthday of the customer from these dates, from today, right, we'll be able to generate the birthday of the customer. So how do we do that? Let's generate a new column. Let's write a business case. That's this. Create a new column that informs the current age of the customers. Now, remember that the questions that you're going to be answering as an analyst are questions that are peculiar to the business, right? Questions that are peculiar to the day-to-day analysis or to day-to-day activity of the business, right? So from these questions, right, you have to be able to generate your logic and business cases out of these questions, out of these things that the sales department will want, the HR department will want, the marketing department will want, whatever department is requesting from you a report, right? So you want to be able to generate, you want to be able to convert whatever they throw at you, convert it into business cases. And in those businesses, you want to be able to generate and convert them into what? Into objects that will help you answer the business cases, right? So if they want to know the average age of their customers, of course, they will not tell you that you should use the current age. You are the one who knows, who need to know that you need to first of all generate the current age of the customers before you can perform that kind of analysis. Are you following me? Right? So let's take, for example, right? So here we're just going to right click and say we want to create a new column. We're going to create a bit of more new calculated columns before we move into measures, right? So we'll say new column. Right, so we say current age equals. Now we have what we call date difference, right? It's also an Excel function, right? That helps us subtract one date from the other, right? This function, date diff, right? Subtract, it takes two dates, right? It takes two dates, and it will tell you, it will give you what's the interval in the 2 days in either month, year, day, and so on and so forth. Let's see, right? So we're supplying AW customer, right? Just let me just say birthday directly, right? Birthday, right? I'm subtracting that from the today function. Remember the today function from Excel. This function would give you the dates, the current system date, to give you the current system date, right? So I want these dates to what? I want this interval to be returned to me in year. So you can see, you can know how old the person is in number of days. You can know how old the person is in hours, in minutes, in months, in quarters, in seconds, in days, and in weeks, right? So, but let's just keep it here, which tells us how old the person is, right? So if you look at it, we can see the age of each of our customers, right? We can see the age of each of our customers. So we can know the customer that is above 50 or customers that are below 50. We can calculate the average age of our customers. We can calculate the average age of our customers. I hope you're following me, right? We can calculate the average age of our customers. Please let me know if you are with me. If I'm too fast, please let me know. If you are with me, talk to me, talk to me. Hello, are we there?
Yes, well, can hear you.
All right. Last week, I also mentioned to us that you can use, moving on from just picking them one after the other, right? Last week, we also talked about the logical functions, right? And we were unable to use the logical functions last class. I know some people still asked me during the week that we didn't use the logical functions last class. Yeah, so we get to see the logical function today, right? Let's go into the calendar column. Right, let's look at the calendar column. Please go ahead.
Okay, in that date, when you were solving the one of that, to know the year of the
age,
date of birth, the age, you use empty column after, I think after the year or before the year. So what does that mean?
Yes, I used the current, this one, current age. Oh, sorry, I mean current age.
You said today, then empty column there. Empty yes. This bracket. I mean,
this today is a function on its own. It does not take an argument, or it does not take any parameter. It's a function that returns the current date. That is how you use it. There are several of them. There's today, there's now, there's year, and so on and so forth. These functions, when you use them, this one in particular will return the current date of the system.
Okay.
Yes.
Okay. Thank you, sir.
Yes, ma'am. Right. So we want to look at the calendar column, right? And we want to know, right? The business case would be create a new calculated column to determine if the order date is a to determine if the order was generated during the week or a weekend order, right? We want to know from the what? From the order date, right? We want to know if the order is a weekday order or if the order is a weekend order. That's by understanding if it's a weekday order or if it's a weekend order, we can determine the total number of orders that came during the week and know the total number of orders that came during the weekend so that we can know and see seasonality in our data, right? If we do more sales during the week or weekend. Are you following me, right? Are you following me, right? So we want to be able to look at that, right? We want to be able to create a column, right? So I'm just going to right click on the calendar date, calendar column, right? And I'm going to say new column now. New column. We're going to call this column weekend. Right, I'm going to call this column weekend. I say equals to if, right, if I'm coming. Sorry, I'm going into the sales table, not the calendar table. I'm going into the sales table. Yes. I'm going into the sales table to do that. Sorry. All right, so this is the other dates that we're talking about. All right, so we say weekend. If order dates let me see. I'm looking at the best way to write this. Okay, before we do that, let's generate the day of the week. Hold on, just hold on. Let me quickly do something. Day of week equals. Can you see from that single statement? I'm generating another statement, right? Day of the week equals order dates. Mm-mm-mm. 1 minute, please. I'm coming. Hold on. Let me quickly delete this. Let me quickly transform this column. Sorry. All right, let me quickly transform this column. Where are we? I use the calendar column. So I go to home, transform. Calendar column. All right, calendar column. All right, so for my date column, all right, I want to know the day of the week. So from this, I'll go to add column. I go to date. I go to day of the week. Yes, day of the week. So this will tell me if the date is a yes. So it will tell me 1 to 7 or 1 to 0 to 6. Yes, 0 to 6. 0 to hold on, let me see. Day of the week. All right, yes. So we have day of the week. Yes, so I'm going to close and apply. All right. All right, so we have the day of the week column now. So this column, once we use it to create a new column, so we say new column. So we say weekend equals if day of the week, right? Can you see the column now? If day of the week is equals to 6. Saturday is 6, right? If day of the week is equals to 6. Or now I'm using a logical statement now. Or that is all. Remember that double ampersand is and, right? So this one I'm using or, right? So I'm saying if day of the week is, remember that we can also write it as the normal way in Excel and say if or, right? We are all familiar with it. So I'm just going to use the other way. So if day of the week, right, is equals to 6 or. Now the difference between that, I remember telling you last class, is that when you use the natural and or, right? In Power BI, it only allows you two logical tests, right? It only allows you two logical tests. But if you use this vectorized this vectorized function or these symbolic and or, using the and ampersand, the ampersand, double ampersand for and, or the double pipe for or, right? It allows you multiple logical statements. It allows you to use multiple logical statements in your expression, right? It allows you to use multiple expression, multiple logical testing expression. So we're going to say if day of the week from calendar is equals to 6, or day of the week equals 7, right? That is Saturday is 6, is the 6th day of the week. Sunday is the 7th day of the week, right? Do what? Return weekend. Otherwise, weekday. Otherwise, weekday.
Mr. Shehu,
Talk to me. Yes, ma'am.
Mr. In the day of week, there is no 7 there. It is 0 to 6. So maybe
Yes. So no, what it means is that we have to look at that data again and look at where maybe the date is not complete, right? But we might not down. There are scenarios where the what's it called? The company might not be, or the store might not be opening on Sunday at the moment. But we want to what? We want to open in the near future on Sunday. So we're creating the functions or the calculated columns that we're creating are not for now only. They are also for the future, right? If we start Sunday operation, right, it means that we can now begin to look at Sunday as part of the weekend. At the moment, in this kind of data, it means that our Saturday is the only weekend day that we open, and every other person what? And every other person what? What's it called now? I mean, every other day of the week is our weekday, right? Saturday is the only weekend. So on Sunday, maybe we do a rest or we take rest on Sunday. I mean, on Saturday. But if we proceed to opening the store on Sunday or making sales on Sunday, taking orders on Sunday, right? Then Sunday now becomes one of the day of the week for us as well. Let us look at it, right? That is why also we used an or statement, right? I did not say and, right? If I had said and, then it would not have worked because it would be considering Saturday and Sunday. But that's why I said Saturday or Sunday, that is 6 or 7. So if you look at our data, right, we have weekday and weekend.
Okay, I understand. Yes.
Yes. Right, so that is how to use the double ampersand or the double ampersand and double pipe in your data set. Right? Can I continue?
So
let's look at a bit of yes, ma'am.
So
Please go ahead.
how can we now know that the order is being made on weekends or weekdays according to the business case that we are looking at?
Remember, let me show you an example, right? Remember that we have linked these tables together, right? Remember that we have linked these tables together. Let me see if I can quickly show you that. Remember that our tables are linked together, and so I have, let me go to my sales table. Oh, I don't have revenue yet. I've not calculated my revenue, right? Let me show you an example. I have all right, let's look at it here, right? Let's take, for example, I have a new matrix, right? I want to know weekday. So if I come here and I say sales, and I go to my revenue, can you see my revenue column? So if I drag my revenue column to my values, or let's not use revenue, let's use total orders. Let me see. Yeah, total orders. Let me use my total orders, right? So this is, let me put it in focus, right? So this is the total order generated, all the orders together, right? But I want to know which order came during the week and which order came during the weekend, right? Because I have a weekend column, I can easily drag that to rows, and it tells me, can you see? Can you see that? It tells me that we have weekday and we have weekend.
Okay, sir.
Does that make sense? Right?
Yes,
so you
yes.
can see the total number of orders that came during the weekday and during weekends.
Okay, sir. Thank you.
Does that make sense?
Yes, it does. Thank
Can
you.
I continue? All
Yes,
right.
please.
So let's go back to our data view. Yes, I hope we're following the way I'm creating these columns and all that. Right, let's create, let's say that we're asked to generate, right, the company that hired us, or our business case is create a new, I'm sure this is one of the questions that we have in that set of questions that I sent to us, right? Create a new column that informs that, create a new column for the short month, for short month name, right? Or for month name with 3 letters. This should not, I can't remember how I was writing that question, but this should be in uppercase, right? So basically, we want to extract the 3 letters from the month and what? And put them in uppercase. So how do we do that? How do we do that? Right? Calculated column again, or new column, sorry, new column again. All of these are Excel functions, so there is really nothing special about them. All of these are Excel functions, right? So you can say, let's say short month equals, now the month name is what we want to use. So we want the first 3 letters of each of these months, right? Of this month name. So what do? We call out that column, right? Call out that column, AW month, right? Go to month name. That is the column I'm interested in. But how do I extract the what? The month name, the short form from that? How do I extract it, right? Remember in Excel, we use what we call the left function. If your data is, if you are extracting from the left side, use the left. If you are extracting from the right side, use the right. And if you are picking values from in between the text, remember we're talking about text now. You are extracting text from the left part of the, you use the left. You're extracting text from right part of the text, you use the right. And you're extracting something from the middle, you use mid, right? So I'm going to say left, right? Left of that. Then I say, how many characters do I need from there? Can you see number of characters? Left, text, the number of characters. I need 3 characters. So if I close that bracket and I hit enter, all right, it's going to generate me that column. Can you see? They are all in proper case. The first letter is what is capitalized. Let's look at what we have, right? Can you see? So this is what we have, right? But remember, this business says that it should be in uppercase. So what do? We do a nested function. Upper, all of these now in what? In uppercase is what we need to do, right? So we'll enclose all of that in uppercase and we'll hit enter, and that would be transformed. Does that make sense? Does that make sense?
Yes, please, yes.
All right. Having said that, right, we want to talk about what we call the related function. The related function. I'm going to talk about this in a more, I'm not going to explain it. I'm just going to show you with example, right, so that you can get it quick, right? Related function, right? There's a filter called related function, or there's a function called related function, and this function works like VLOOKUP in Excel. Now, the reason why it works like VLOOKUP is that, of course, you know that Excel is a referenced application. It's a reference-based application, which means that the cells have to be referenced, right? So when you want to import a particular value into what? Into a cell or into a column in Excel, what we use VLOOKUP, right? You must know the lookup value. You must know the table array. You must know the column which it is, where it is coming from, and you must know if it is what? If it is a false, I mean, if it's an exact match or an approximate match that you're looking for, right? But because Power BI is not a cell reference based environment, right? We have functions that can help you import data from another table, right? So take, for example, right? I want to go to my sales table, right? I want to go to my sales table. This is my sales table here. All right. I want to know what is the product price for each of these items. This sales table does not tell me much about it, right? It only tells me what's about the others, right? But I want to be able to say, what is the product price? What is the product price of each of these items? What is the product price of each of these items, right? How do I get the product price? If you go to the product table, you will see the product price on the product table. Can you see the product price for each product? You can see the product price and the cost price, the product price and the cost price. You can see for each of the column, right? Product price for each of the column and the cost price for each of the column. Let's make them in currency. So I need this product price on my sales table. Are you following me? I need this product price on my sales table. So how do I get that product price to my sales table? We use what we call the related column, right? The related column. So what I'm going to do is I'm going to go to my sales table, right? So I'm going to call it retail price. That's new column now. Right? So we say retail price equals, now I use the word related, right? I use the related function, right? Can you see related, relatable, related table are the two functions, but I'm using related here. So related, what column am I relating? What column am I inputting? The product price column. Right? The product price column. If I close that and I enter, right, it would import that column for me. Can you see? The product price column is now inside of my sales table. Remember, we're inside the sales table, right? So look at it. The product price is now the retail price. Can you see? The retail price. Now, I want to know what is the revenue generated by each of these orders. I hope you are following the third line, my third line, right? Or my thought process, right? I want to know for this order that was generated in 1st of February 2016. I want to know what is the what's it called now? What is the revenue generated by that, right? Revenue therefore will be what? Will be the quantity column multiplied by what? By the retail price. Ordered quantity multiplied by retail price. So what do? We create a new column. Can you see how we're transforming the data, right? Create a new column, call that revenue, right? Equals to order quantity, which is a column, multiplied by another column, which is called retail price from the same table, right? If we hit enter, right? That column gets what's generated. Right. So we have the revenue column. So if you look at it, you have 1 multiplied by 2049, which gives us that. But if we scroll down to where we have multiple orders, can you see? So we have 2 multiplied by 499, gives us what's 9.98. Can you see? So that is our revenue. That is our revenue. That is our revenue. Can I proceed? Right? I'm going to stop there on calculated columns, right? And I'm going to show us measures a little bit. Let's see a bit of measures. 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 Right? Let's start from total revenue. Now that we know the total what the revenue for each what's called now order, right? Let us calculate revenue by each order. Right? Calculate the total revenue generated by each order, right? So I'm going to create now. We have the revenue column now. So this value now, this total revenue, by total revenue, not by each other now. We have the total revenue by each other already. So we have the total revenue for all the sales, right? So we want to know what is the total revenue, the sum of all this revenue, right? So what do? We right click on that and we go to what? Measures. And remember, I've told you that when you are creating measures are basically used to what? To create aggregate functions, right? They are used for what? For aggregate functions, right? So if I say total revenue now, right? Total revenue will be equals to the sum, right? Sum is an aggregated function, or sum is an aggregate function, right? So we say sum. Sorry, somebody is trying to join the class. So we say sum. What column are we summing together? Sorry. Yes. So what column are we summing together? Revenue. Sales revenue. Right. If I close that now and I hit enter. Are you following me? So now we know the revenue. So if I click on revenue now, total revenue, can you see? That's the total revenue. The total revenue generated by all the products is 24,914,567.18, right? I can now say, okay, let me break this revenue down by what? By product category, right? By product category. So let's go to product category just so that we can see. Right? Can you see? This is the breakdown of all the sales. Can you see? This is the breakdown of the sales by what? By product category. Accessory, bikes, and clothing. Right? So this is how they have what? That is how they have generated the what? The values. That is how they have generated the values. So we can see, if you remember from Excel class, right? This will be a sum if kind of expression. Are you following me? I hope we're there, right? This will be a sum if kind of expression, right? In Excel, you can calculate this with sum if in Excel. All right, so number is formatted now. So you can see that is what? That is a measure. That is a measure. That is a measure, right? That is a measure. You see that it has, I told you last class, it has that what? That calculator icon in front of it. Let's create another measure. Right, we want to know, let's go into the returns table. Let's go into the returns table. So we'll go back to the data view. Let's go and see what we have in the returns table. Right, so we have the returns table. All right, we want to know what is the quantity of products returned. All right, we want to know what is the quantity of product returned. What's the quantity of product returned? How do we do that? Right, we sum up what the return quantity column, right? We sum up the return quantity column, right? So you using a measure, right? So we say quantity returned will be the sum of what? Quantity returned is equals to the sum of what? Of the returned quantity from the returns query. We hit enter. Right, let's go back to our report view. Right, from the report view now, let me see. So from the report view, let me show you. So I can see the quantity returned. The total quantity returned is 1,828. But we want to be able to break it down to product category. How many accessories were returned? How many bikes were returned? How many clothing were returned? Madam, Olapoju, please talk to me. I'm just seeing your hands raised. Please talk to me.
Okay, please don't worry. You've been able to answer the question.
Awesome. Awesome. All right, are we good to go? Can I continue? Can I continue?
Yes, please.
Awesome. All right, so having talked about orders returned, we want to know, let's see else, what else can we, I'm trying to see how much I can bring a whole lot into this. All right, let's look at quantities sold. Just want to copy DAX and paste, copy DAX and paste, so we can move fast. So if I copy this, right, we want to look at what is the total quantity sold as well. Total quantity sold, right? Total quantity sold. Basically, the total quantity sold, right? Let's create a new measure. Will be sum of everything, sum of every order generated, right? Sum of every order generated. That's what you have. Can you see? Quantities, sum of order quantity, right? Quantity sold. Have we done that before? No. So we hit enter, we have sum of quantity sold. Can you see? So if we go back to DAX now, let's let's add these to this report. I think I misspelled this here. Okay, let's just continue. So to this report now, if I had quantity sold, can you see? This is quantity sold and this is quantity returned. Can you see? Quantity sold, quantity returned. So we sold 5,000. Hold on. 57,000, sorry. 809 accessories. But 1,130 of them were returned. Are you following? 1,130 of them were what? Were returned. So that tells us, gives us an estimate of what was an actual value of what was returned. And the total quantity sold is 84,174, and we have 1,828 items returned. But what basically is the ratio? How do we measure? We want to be able to say, of the total percentage of accessories bought, this is the percentage that was returned. How do we do that, right? How do we do that? We create another measure, right? We create another measure. So this time around, we're creating a measure in the returns table. I'm going to call that return rate. I'm going to create a measure. I'm going to call it the return rate. If you check, I'm answering some of the questions that are already in that business case that I sent to you, right? So I'm going to say return rate equals simple. Return rate will be what? Quantity returned. Sorry. Return rate will be quantity returned divided by quantity sold. Quantity returned divided by quantity sold. That will give me my return rate. All right. So if I had that to values, if I had return rates to values, right. All right. So can you see? So it tells us that of the 57,809 accessories sold, right, 1.95% of it were returned. So if you look at it, we have the highest number of bikes what's returned, right, in terms of percentage, right? So this value does not give us that particular analysis, right? But you can see that we can see the analysis from here that we have the highest return rate is from what? Is from the bikes is from the bikes category. Are you following me? If we want to see more on that analysis and say, okay, what subcategory of bikes were returned, right? We can just go into the product subcategories and bring in the product subcategories, right? So if I bring in the product subcategories, we can see a drill down. Right, so you can see inside the product subcategories, inside bikes now, we can see that there is a particular road bike, touring bike, sorry, that has about 3.30% return rate. We sold 2,124 of it, and 70 were returned, right? But it has the highest it has the highest return rate. The cumulative of them is what gives us the 3.08% return rate. I hope you're following me. I hope you understand what we're driving at here. I hope you understand what we're driving at here.
Yes.
Yes, we are following, sir.
Awesome.
We are following. Thank you.
All right. Right? On the product table, can even take it a little bit further and generate the average using a new measure now. I want to generate what the average product price is. What is the average product price? All right. I want to generate what the average product price is. Or average is as average retail price, right? So if we say average, so the average retail price equals to the average of the product's price column.
Mr. Shin.
Yes, ma'am.
Okay, sorry to take you back. I just want to confirm something. I thought the
Please go ahead.
cumulative, the total of all the subs under the bike is supposed to give us what the percentage of the bike is.
I didn't get that.
All those road bikes, mountain bikes, and touring bikes. The
Yes.
total of it, the total of the percentage, the return rate, is it not supposed to give us the bike? That of the bike.
No, that's total divide. That will be the sum of this divided by 3.
Sorry?
That will be
Because if you
3.14
look at the
plus
return rate,
2.89.
if you look at the quantity return, is the total of it that gave us 429, Abi?
420. I'm trying to see 429. Where did you see 429? Okay, this year.
For
this is
bike,
the total return
yes.
for all of this. Yes.
So I'm saying for the return rate, is it not supposed to be?
No. The rate, our rate is calculated differently. If you want to calculate, if you want to know the return rate now, it will be the sum of all of this. 3.14 plus 2.89 plus 3.30 divided by 3.
Oh, okay.
Yeah.
Thank
Do you
you.
understand?
Yes, I do.
Awesome. All right. So we just calculated average product price, right? The average product price basically will be the sum of all the products divided by the number of how many of them were sold, right? That is what you have, right? Let's look at it, right? So this is the total. Let's give that measure a. All right, so this is the average retail price for each of the category, right? So put all the categories together, right? We are price and divided by the quantity that was sold, right? This is the average price for each one. So if you look at it, the bikes have the highest average, meaning that the bikes are they are the product item that we have that are weighty, right? That are probably very expensive, right? And if you look at it, right, if we do a deeper dive into the data, I discover that if we go into the analysis by order, you discover that they were sold singularly, right? Unlike time will not permit us to do that, right? Unlike other products, accessories, people will buy several accessories together. People will buy several clothing together, right? But if you look at, if we do that analysis for products, for the bikes, you discover that they were sold as single items. Remember that we did multiple items and single items the other time, right? If you use that column for the analysis, you discover that most of the single items or bikes are basically bought in single items, right? They were not bought they were not bought as an all with several other items as a single order. That's basically what I was trying to say. So you can see by looking at what's the average price, we're able to determine, right, what the average price is for each of the category. But if you look at the last component, it was not showing before. Let me disable that so that you can see. Right, you see that initially what we have was just three categories, but by what also bringing in what's the average price now, right? You can see that the fourth component short fourth, and it's telling us even though sales were not made for it, this is the average price for it, right? Even though sales were not made for it, this is the average price for it, right? So that is that, right? Let's look at a bit of let's look at a bit of count. Let's use count and distance count in this analysis. Right? Even though this is our the quantity sold, let's go back to quantity sold. I want to show you something. Just follow me bumper to bumper. Right? This is the quantity sold. If I do a measure, sorry, if I do all right. If I do a measure for all right, I want to do a measure for the total orders, right? Total orders. Let's know how many orders were generated. So we say sum of order sorry, not sum. Sum will give me an error. I'm supposed to do a count. Then yes, it's going to give me an error. So I'm going to edit that. Supposed to do a count there. Count, sorry. All right, so this is the count of the total what? Of the total order. If you look at your data, right? If you look at the data in the data view, right? You see that the total rows in this column is 56,000 and what 56,046. So that's the total number of rows in the data. That's basically what we have, right? So we count the total number of what? That's what we're doing. We counted the total number of orders, right? But remember, we said that some orders are what? Some of the orders are duplicated, right? So how do we know the number of distinct orders that we have? How do we know the numbers of orders without what? Without duplication, right? Let's create another measure. This time around, we want to use distinct count. We want to use a function called distinct count, right? Distinct count. So if I say total distinct order equals distinct count. Can you see distinct count? Right, it says count the number of distinct value in a column, right? Distinct count in what? Other number, right? AW says other number. All right, so now we want to be able to what? We want to see the difference between these two values, the total orders and the distinct count. Can you see? So our distinct count actually is what? Is 25,000 and what? 25,164, right? But we have that orders, the values are what? So we have the difference as what? As the number of duplicates. The difference between these two is the number of duplicates that we have. Are you following? It's the number of duplicates that we have. So this is how to what? To how to know the number of distinct values in your data, right? Using this what? Distinct count. So we've used count, we've used what? Distinct count. You can also use what we call count rows, right? If I want to know the number of rows returned, let's go to the return table. Let's use that in the return table. If I say new measure, and I say total returns is equals to count row, right? Can you see count rows? Whatever you count your rows, the same thing with count, right? Count rows, right? And I say return. AW return. Can you see? Count the rows in this table. Count the rows in this table. All right, so it's the same thing as, so if I go back, let me go back to my report view and right, so if I drag this down into what is it now? Total return, right? If I drag it down to quantity returned, you'll see that they will give us the same set of values. All right, so you'll see, so total returns is, let's break this down, hold on. All right, so there are a bit of duplicate values removed in between, can you see? So basically, you see that what quantity returned and total return did not give us exactly the same value, which is supposed to, right? But basically, what you have in total returns basically is it removes the duplicates, right? It removes the duplicates where there are duplicate values. That's basically what you have. Yeah, this is an implicit function, and this is an explicit function. This is just done by what? By just dragging the column. What is it called? Oh, sorry, both of them actually, I just saw it. Both of them are measures, right? Total quantity return, yes, sum and count. All right, good, which is perfect, right? This is perfect. This explains it, right? So if you look at it, the quantity return basically is what? Is the sum of what? The return what quantity, which includes what? Duplicated values, like I mentioned earlier. But this one is a count of what? Is the count of the rows, which removes what? The duplicate values, right? So that's basically what you have in those two cases. Let me see, what else can we talk about? There's several things that we can talk about in measures. Like I said, I will send us my full-blown what's it called now? Power BI file, so that we can see. You would see, once you just see the files, you can just see how each of those values are generated, or how each of the measures and calculated columns are generated by just clicking on them. Like if you click on here, you'll see how this was generated. If you click on here, you see how they are generated, so that we can get up to speed, right? So that we can get up to speed. Tomorrow, we're just going to move into visualizations very fast so that we can wrap up, right? Please and please, we've tried in this program. I don't want to extend it any further. Who is just joining? Right? Any question? If you are lost, let me know. If you are lost, let me know. Any question? Right? There are some functions, there are some DAX functions that I've not been able to talk about. Take, for example, like all, how to use the all function with calculate. Take, for example, we've not been able to look at calculate, right? We've not been able to look at calculate. We use calculate to perform a bit of functions or a bit of analysis with filter context, right? We use calculate to calculate orders. Take, for example, let me give you an example. It's easy to explain these things with an example. Let's say that I want to know what is the total orders for weekend. What is total weekend orders, right? What is total weekend orders? We did that somewhere here in the calendar. I showed us earlier, right? But if I want to calculate that, right? If we want to calculate that, we use the calculate function, right? We use the calculate function to create a measure. Let's see if we can quickly do that before we wrap up. So using the wicked functions, right? We'll say new measure. Let me show you an example, right? So the calculate basically takes two arguments, right? It takes the argument of the measure that you want to perform the analysis on, and sorry, I'm creating that inside of returns, which is wrong. I'm just going to go to sales, sorry. Right, so the calculate function takes a measure, right, and it helps us apply it allows us to apply a filter context on a measure. A filter context basically is a where clause, basically, right? A where clause where this is greater than this, where that is greater than that. That's what we call filter context, right? Before you think I'm saying plenty English, right? So basically, filter context is basically applying a filtration to your analysis, right? So take, for example, if I say I want to know weekend orders, right? And I say, take, for example, let me show you. Say calculate. So you use the calculate function in these scenarios, right? Weekend orders. Be equals to calculate. Right, now can you see it's asking for what expression and what filter do you want to use? Expression and filter. In this situation, my expression is total orders, right? I created that already before to let me know the total number of orders, right? And after that, I want to know, right, what is the total orders, right? But the total orders, now what I'm saying is calculate the total orders, but only for what? Only for the weekend, what? Only for the weekend data, right? So I'm going to go to calendar. I'm going to calendar, AW calendar, weekend column, right? And I'm going to say where that is equals to what? Weekend. Right? Let me explain this now. So it's going to apply this filter function on this measure, right? This measure, undo, right? This measure was to tell us what the total order were, right? What is the total orders? That's what this measure is, right? Now, when I'm saying that from this measure, can you filter out the ones that are just for what? For weekends or for the weekend, right? That is what you have using the calculate function. So calculate function makes it possible for us to do an analysis, like apply a filter context on a measure, or on a DAX expression, not just mentioned. You can apply them on calculated columns as well, right? So it allows you to apply a filter context on an expression. That's how I'm going to say it, right? It allows you to apply a filter context on an expression. Are you following me? If I say enter now, right? And we click on what is the weekend orders now? Right? Can you see weekend orders is what? Weekend orders is 7,877, right? 7,877. That's what you have for the weekend orders. If you look at what is total order, let's see. Total orders. Total order is what? It's about 25,000. Oh, 56,000. Yes, good. 56,046. That's what we have, right? Let's do it this way so that we can see both of them in context, right? So if I say total orders and weekend orders, can you see? Total orders, weekend orders. Total orders is 56,046. Weekend orders is now that we have extracted the orders from the weekend from the total order. So it's telling us that this is the total order for weekend. So you use calculate functions to do that. You use calculate functions to do that as well. Right? Let us see one more calculate function before we move to some other things that I want to talk about. All right. Let us see bulk orders. Let us look at bulk orders. We want to know what are the orders, how many bulk orders do we have? How many bulk orders do we have? How many bulk orders? These are orders where the quantity or the order quantity is greater than one. We want to know bulk orders. Bulk orders for us would be orders in which the quantity inside the order is greater than one, right? So in that situation, remember that we have created total order. Everything is inside of that total order. So we're going to be using the total order again. So we're saying bulk order is equals to, calculate now, takes the expression total order, right? Now, what are we applying? We're applying to say order quantity, where order quantity is greater than one. Then that will be what? That will be a bulk order. Once order quantity is greater than one, it will be what? It will be a bulk order. All right. If not, to be what? To be a single order. Remember that we created a column earlier that tells us if the order is what? If the order is a single item order or a multiple item order. All right. So all of these are what we're now interpreting gradually, right? So if we look at it, if I use let's use bulk order now. All right. So we have how many bulk orders do we have there? We have 24,625 out of what? Out of the total orders that we have. The total order that we have is 56,046. Total order is what? 56,046. Can you see? So out of that, right, 24,625 are what? Are bulk orders. Can you see the way we are answering business questions? So the company wants to know how many bulk orders do we have. The company wants to know how many distinct orders do we have. The company wants to know how many all of these do we have. How many all of that do you have? So you see the way we are creating them based on what the expressions, just applying expressions and applying expressions on the data using data analysis expression. These things are not hard, right? You can do these things with Excel. You can do them the same way in Power BI. Any question? Any question? We have 3 minutes to 9. 3 minutes to 9. Any question, please? Any questions? Tomorrow, I'm going to be coming with a full-blown maybe I'll just share it this night, right? A full-blown, but the full Power BI expression, or the PBIX file that we'll use tomorrow, so that we can follow through. Any question, please talk to me. I hope we're not bored. Talk to me. Any question? Don't worry, you might not get them accurately now, right? But if you rewatch the video once again, you would understand them better. Now, what I want you to get out of here is just the way we've been using data analysis expressions to answer business cases. That is the most important thing that I want you to see here. I want you to see it. The way we have been using data analysis expression. It's the same way that we do them in Excel. All of these things that I'm doing here, we can do the same thing in Excel, right? Using pivot table, using what's called, you can use data analysis expression as well in Excel. And of course, writing just basic formulas as well. You can do all of these in Excel. So it's just the same way, right? Same way we've been doing that. You know how to use average, you know how to use sum, count distance. All of these also exist in Excel. So there is no difference, right? There's little difference. That's it, right? So you just need to be able to know how to interpret the business case into your logic or into expressions, and be able to break it down and apply your formulas to generating to interpret them, basically, so that you can generate your result. Any question before we call it a day? I don't know what to keep us beyond time. Any question? Tomorrow, please prepare. Please check your emails this night. You'll get your project this night. Let me give you an idea of what your first project would be. The idea is that these I wanted to give us different projects before, but I said I thought about it and I said no, I've already developed that already. I was like, nah, let's foster. Let me use this project to foster collaboration amongst us. I want to see. I'm not going to peer us. I'm not going to do anything. Each person is going to submit their report individually, but I want to give us the same project. I want to give everybody the same project so that we can collaborate, right? We can share ideas to deliver your project, right? You can share ideas, you can collaborate with each other. I want to be able to see and use this avenue to be able to foster collaboration amongst us, right? But I'm sure I leave us to it to be able to do that at our own discretion, right? But you see this data that we have here, all this AW AdventureWorks data that we have here. We want to I want us to create this same model in SQL. That's our SQL project, right? So you would have to interpret exactly this model in SQL. So what you would have to learn is how to create. You have to create each of the tables in SQL. You have to import the data in SQL, and you have to create these you have to create this relationship in SQL using your primary key and foreign key. Then I will now give you business questions, like all of these business questions that we're interpreting at the moment. You now use your SQL knowledge of your select statement and all of that, and other functions of SQL statements to answer those business questions, right? So that will be our first project, right? And our Power BI project has another data set that we're going to be working on. So we have two projects to submit, right? We have the SQL project and we have the Power BI project. But I'll give us a detailed explanation on the project. So please check your email addresses that you submitted when you registered to be able to see your project, right? You'll get your project this night by God's grace, right? Our program coordinator also dropped a feedback form. Please help us fill the feedback form so that we can know how to make this program better, so that we can learn better and improve on our own delivery from our own end, right? So please help us fill that feedback form. I'm expecting everyone to fill the feedback form. If you enjoy the program, let us know. If you have issues, let us know. If you any way you think we can improve, please just let us know so that we can work on that. Right? Tomorrow we're rounding up. Rounding up. Hopefully, I hope that yes, I want us to start by 6 tomorrow. So please prepare. We'll start by 6 tomorrow. We'll look at data analysis, visualizations, how to create visuals from the reports that we have generated from all these calculations and all these calculated columns and measures and the columns that we have. We want to be able to now turn some of these analysis to visuals, right? Very simple and straightforward stuff tomorrow. We'll look at how to do that. Then hopefully would I promise to touch on Git. I hope we would have enough time to touch on Git tomorrow. If we cannot touch on Git tomorrow, I'll drop a material for us to use on Git tomorrow, right? Any question before we call it a day? If you enjoyed today's class, can I get a thumbs up or something before we round up? Talk to me, people. Thank you, Ma. Thank you, Ma. Thank you, Ma. Thank you. Where's Ebuka? Ebuka is not in class today. Thank you. Thank you. Thank you. Mr. Lawans, are you still there? Madam. Let me pause my